Hi everyone, welcome to today's lesson. The learning target is I can graph hyperbolas. The do now is a past question. Find f of g of x if f of x is equal to 2x squared plus 1 and g of x is equal to x plus 3. Now remember, because g of x is inside f of x, we're going to put x plus 3 inside f of x. So 2 times x plus 3 squared plus 1. I expand x plus 3 squared. And then I simplify by distributing and adding the 1. So my final answer is 2x squared plus 12x plus 19. For today's lesson, we're going to focus on a hyperbola, graphing a hyperbola, and talking about its characteristics. So a hyperbola is the set of all points in a plane whose distance from two fixed points, or the foci, have a common difference. So let's take a look at what a standard form of a hyperbola looks like. So we have x squared over a squared minus y squared over b squared is equal to 1. Notice if the x is in the front, then it's a sideways hyperbola, which means that the vertices are on the x-axis because x is positive. So your vertice negative a comma 0 and a comma 0. Whereas if you have y squared over b squared minus x squared over a squared is equal to 1, the y is positive, which means the hyperbola is on the y-axis. So 0 comma a is one vertice, and 0 comma negative a is the other. Again, it says, did you notice the minus sign? That's how these differ from ellipses. So the minus sign is in between. That's how you can figure out that it's a hyperbola. And again, it's always still equal to 1. Next, to find the foci, it's c squared is equal to a squared plus b squared. Foci is on the same axis as the vertices, so negative c comma 0 and c comma 0 when it's on the x-axis, and 0 comma negative c and 0 comma c when it's on the y-axis. Finally, with a hyperbola, we have asymptotes. These asymptotes are going to pass through the center and the corners. We're going to be drawing a box, which I'll get into more details later. But we have y is equal to plus or minus b over a x when it is on the x-axis. So notice here, if here's my hyperbola on the x-axis, I'm going to have asymptotes right here. And then vice versa for when it's on the y-axis here and here, I'm going to have asymptotes here with plus or minus a over bx. Notice that my f here and f here are my foci, which is on the major axis, along with here f and f along the major axis. Let's go to our example. It says, example, finding the vertices and foci of a hyperbola. 9x squared minus 4y squared is equal to 36. Now notice it's not equal to 1, but I know that it's a hyperbola because there's a subtraction sign in between. So I have to divide by 36 to each term. So I end up getting x squared over 4 minus y squared over 9 is equal to 1. So this is my standard form of my hyperbola. So let's graph it. So I'm going to draw my y-axis and my x-axis. Now because my x is positive, I'm going to go to the left to plot my point, the right to plot my point. This is going to be my hyperbola. Again, remember you take the square root of 4, which is 2, and the square root of 9, which is 3. So I'm also going to go up 1, 2, 3, plot, 1, 2, down, 1, 2, 3, plot. So I know my vertices are here and here. So I'm going to have 2 comma 0 and negative 2 comma 0, or vice versa, I should really put. It's positive. Now, to find the foci, it's a squared plus b squared is equal to c squared, which is really the square root of 9 plus 4, which is 13. And again, my foci is going to be on the x-axis because x is positive. So it's going to be here and here, which is approximately plus or minus the square root of 13 comma 0. Now, I know this question doesn't require us to find the asymptotes, but I want to show you anyway. It's plus or minus b over ax, the asymptotes. So that would be plus or minus 9 over 4, which simplifies to 3 over 2 x. So notice I'm going to go from 0, 0. I'm going to go up 3 and over 2, going to plot a point. And I'm going to go opposite, so down 3 over 2, plot a point. Same over here, and same over here. I'm going to create a box like so. And then really, my asymptotes are through here and here. And that's how you graph a hyperbola. If you go to the next page, it gives you the steps. So step 1, plot the main points. Step 2, draw the rectangle connecting the points, which we just discussed. Step 3, draw lines through corners. These are your asymptotes. And finally, step 4, draw the hyperbola. Now remember, if the x is in front, the hyperbola vertices are on the x-axis, and vice versa. If y is on the front, the vertices of the hyperbola are on the y-axis. Let's go to the next question. So it says, sketch the following hyperbola. X squared over 3 squared minus y squared over 2 squared is equal to 1. First thing you do, you're going to plot the points. So negative 3, 0, 3, 0, 0, 2, 0, negative 2. Second step, you're going to draw the rectangle using these points. And then you're going to draw through the corners. Now, the formula is going to be y is equal to plus or minus b over ax, which is y is equal to plus or minus 2 over 3x. So that's why we're going up 2 and right 3. Down 2, right 3. Same idea over here and over here. Step 4, since x is in front, it's a sideways hyperbola. These lines are the asymptotes, and the graph hugs the asymptotes. They get closer and closer, but never touch. Take a look at the next 2 practice problems and see if you can do them on your own. Pause the video. Notice I have x squared over 16 minus y squared over 4 is equal to 1. There's a minus sign, so we know it's a hyperbola. And it's going to remain on the x-axis because 16 is going to be going to the left by 4, right by 4, and x is positive. So I'm going to put my point here, up 2, down 2, because the square root of 4 is 2. There I get my box. And then again, to find my asymptotes, it's going to be b over a, which is 2 over 4, which is 1/2. So I'm going to get my asymptotes to be approximately here and here. My foci would be 16 plus 4 is equal to c squared, which is really plus or minus the square root of 20, which simplifies to 2 radical 5. It's going to be on the x-axis approximately here and here. For question number 2, y squared over 1 minus x squared over 16 is equal to 1. Y squared is positive, so my hyperbola is going to be on the y-axis. I'm going to go up 1 and then down 1. And then I'm going to count over left 4, right 4 to create my box. My asymptote is going to be plus or minus 1 over 4, so go up 1 over 4, and there's going to be my asymptotes. My foci is 16 plus 1 is equal to c squared, which is radical 17. Again, my foci is going to be on the positive axis, which is going to be the y. So it's going to be approximately here and here, 0, radical 17, 0, comma, negative radical 17. And don't forget that my vertices are 0, 1, and 0, negative 1. This is my hyperbola. And finally, the last question, it gives us the graph of a hyperbola with the rectangle graph along with the asymptotes. So I know it's on the x-axis, the hyperbola, the vertices are, so it has to be x squared over 4 minus y squared over 9 is equal to 1. Remember, there's 2 left, 2 right, up 3, down 3. That's how I'm able to get 4 and 9. My domain is negative infinity to negative 2 included. Unioned with 2 to infinity, the 2 is also included. My range is all reals, or negative infinity to positive infinity. My vertices are negative 2 0, 2, 0. My asymptote is b over a, which is plus or minus 9 over 4x, which simplifies to plus or minus 3 over 2x. Finally, my foci is c squared is equal to 9 plus 4, which is radical 13 plus or minus radical 13. And because I'm on the x-axis, my foci would be here and here on the x-axis. So it's radical 13 comma 0, negative radical 13 comma 0. Hope this is helpful. If you have any questions, message me on Teams. Thank you. Have a great day.